Yeah. Hello, everybody. So it's a great pleasure to be here, and I'm sorry I could not attend in person. I have too much traveling lately, and so at least online. It's thank you for inviting me. And so first of all, to introduce myself a little bit. So my three main affiliations are the following. Um, we run a family business called Greenville. We are a company designing, installing, and maintaining green roofs. We have been doing that for 12 years, having some prior experience as well. And together with other companies, not only installation companies, but also suppliers of green roof components, we are associated in the Czech Green Roof Association, which is the second logo that you can see. And in the association, we are also doing a lot of um, voluntary work, but also interesting projects such as the Green Roof of the Year competition. We are publishing a lot. We published the Green Roof standards. We cooperated on various other publications, which are freely available on the website. So feel free to visit that one as well. And with the Czech National Association, we are a member of the European Federation of Green Roof and Living Wall Associations, which is an umbrella organization bringing together about 17 national associations from all over Europe. And I've heard that many of you are from abroad, so do click on the website of the EFB to find out if there is a National Green Roof Association in your country as well. I heard that there is someone from Scandinavia, so Scandinavia has an association as well. Pretty much most of the European countries do. So, so this presentation is going to be about green roofs, which obviously is not this. This is how green roofs were viewed not so long ago, still. So rather something undesirable, accidental, dangerous, potentially. And with the work of our association, also with help of many installation companies, we managed to showcase the good examples of green roofs, what they actually are and what they actually can bring. And that's these beautiful projects, such as the Main Point in Prague, which you can see in the picture. This is on top of an office building in the business district in Pankráč in Prague. So some of the roofs are private, and most of them are publicly accessible to all the office workers in the building. Or this green roof, which is in the very center of Prague, and that happens to be a pitched intensive green roof, which is rather unusual for green roof, but it's a beautiful project, also an award-winning project that we have right in the center on top of a historical building, so all the more interesting. This one, an example of a project that we see quite often, so some landscaping architecture on top of underground garages, which is also a green roof because it's greenery on a structure. Or we also showcased projects from family houses, smaller but nonetheless beautiful projects like this one. Or this one, that's also a private project, including a small lake with living turtles. And this is, again, an office building in Brno, the second largest city. So green roofs can be successfully combined even with some water basins and with some water elements. And so that's really the fantasy can spin. So I have a lot of pictures, a lot of information that I can share with you, and would like, because I'm so distant, I would like it to be slightly more interactive if we can make it. So if you have any questions, if you would like to have something answered throughout the presentation, just don't hesitate to let some of the organizers know, because I won't be able to see your raised hand, but the organizers will. So do let them know, and they'll stop me, and I can get back to your question. Yeah, and for those of you who are online, the same. Just shout out and let's talk. And I would also like to know, and that is where we get to use the Mentimeter. Would also like to know what you are actually interested in. If you can use your cameras to scan the QR code on the screen, would be nice. And you can type in a couple answers about what you would be interested in seeing in this presentation. And although I've prepared the presentation in advance, I'll try to, based on your answers, I'll try to stop at the places where you've mentioned that you were interested, and elaborate a little bit more. So let me know if it's working. So far, I don't see any response there. Okay, great. I already see something. Great. I'll stop sharing this particular screen, and I'll share the screen with the answers. Just give me a second. I believe it's this one. Okay, so that's the responses that we have so far: vegetation, irrigation systems. Okay, that's a good point. I don't have much about irrigation systems, to be honest. Gray water use. Great. Yeah, perfect. Plants and rooftop technology. Great. Great. Yeah, that's really interesting answers. Thanks for that. Actually, I see one common topic that we can address right off, because I haven't included that part in the presentation, and that is the problem, the thing of irrigation. So obviously, certain types of green roofs need to be irrigated, and that's really dependent on the climate. So I know that you come from various climate zones in Europe. I'll be talking about the Czech local climate. So we need to irrigate the intensive or semi-intensive green roofs, and obviously it's a big thing, to choose the right source, the most economic and environmentally friendly for the irrigation. So the number one choice is to use the rainwater, which is being harvested either from the very roof or from some other roofs. And the second choice, which is just developing, we had some legislation hurdles there, but that was the area of the gray water. And obviously, buildings produce a lot of gray water, which needs to be purified to a certain level that it fulfills the hygienic criteria. And that's where the laws actually come into effect, because the laws specify, the legislation specifies the hygienic parameters to use the gray water for irrigation. It's not such a big thing for the drip irrigation. That's really it's not the problem, but the problem is when you want to spray the water using sprinklers. So our legislation would not allow us to use gray water for that, unless the gray water would be so hygienized that it would comply with the public safety law. But obviously, gray water is an immense source, so the legislation thing needs to be sorted out. Great. How thick is the substrate? Okay, how much can it hold? All right. Great. So I'll skim through this, and in case we come to talk about any of these or come to touch it, just feel free to post your question, and I'll try to address it. Yeah, capture it, CO2. Yeah, great, perfect. All right, so I'll get back to the presentation and show you the slides. Great. So now we should be seeing the PowerPoint again. So where we are right now, we are at a rather unfortunate point of time in history, where we realize how much CO2 emissions we have actually pumped into the atmosphere. And we realize that it's not sustainable. It cannot go like that. We're already seeing consequences. There is a 99.9% consensus of science that the CO2 emissions are actually human-made and are contributing to climate change. Although we might still be hearing some voices, especially in our country, which try to object to this, but there is a really strong consensus. Now, looking at the past couple of years, we see that the total emissions of greenhouse gases are composed of two main gases, CO2 and methane. So methane being the light blue curve, which is at the bottom here, and the CO2 being here. And altogether, they add up to the green curve. What we also know is that in order to achieve the 1.5 degree scenario, we need to stick to this curve. So 1.5 degrees is the preservation of functioning ecosystems that scientists can agree on. 2 degrees, they don't really, all of them agree on 2 degrees. Most of them say it's too much already. So far, we're not on either of those curves, unfortunately. And the green roofs can actually, just like any other plants, they actually sequester carbon and can help us really using low-tech solutions, using natural solutions. They can help us get back on track, and we desperately need that. So the climate crisis is not the only one that we're facing. We're facing also the biodiversity crisis. So the loss of biodiversity across continents in the world, and in some continents is more severe, some less. But here again, also green roofs and green infrastructure can help us address this topic, because we can specifically create habitats which we know are being destroyed in nature, and we can compensate in the built environment for that, and also in the agricultural land, but I'll focus on the urban environment right now. Now, some of us seeing these pictures, seeing these charts, it may seem a little bit, heavy, and that we almost feel, anxious. But yeah, I'd like to know how you actually perceive this, because it's everybody has a different perspective on this, and I've asked this question a number of times at different venues and different audiences, and I'd really like to know what your opinion on this is. So if you can use your Menti again on the smartphone, and just and here I see that I have not translated it actually. Yeah. So anyway, so those of you who want to vote, just feel free to let me know, and we can see some statistics there. And in case you don't understand the answers, which I unfortunately have not translated, sorry for that. Just we can skip this. So I don't see any answers there, so we'll just skip this. But I'll give you an interesting observation that I had, because I've asked this question at a landscaping school and ask it to civil engineers, and the landscapers, the future landscapers, were slightly more anxious seeing the charts, and the civil engineers were really balanced. So some of them were totally fine and totally unaffected by climate change, and some of them were slightly worried, which also tells us something about how engaged are the key stakeholders with respect to what we need to achieve. So anyway, this is the school, your school, or the school that you were visiting. You can see the environment of the school. You can see how many green roofs there are, how many there are not. And looking at it from this perspective, we realize that the more we build, the more we actually need greenery. The more greenery becomes scarce, and we need to compensate for it in the built environment, which is, I think it's a no-brainer, but still sometimes we need to remind ourselves that the civil engineering development is not really a panacea. It will not bring by itself what we're looking for. So looking at your school from a different perspective, we realize how many surfaces there actually are artificially created on the same area. So we see the surfaces of roofs, but also the surfaces of facades, and all of these surfaces have a potential to accumulate heat, to radiate heat back, to reflect sound, to or not to trap dust particles. Yeah, so this is the picture of civil engineering as it is, so the state of the art, and we're trying to change that. We're trying to make it better. And this is some inspiration from the nature. So this is one of my favorite climbing locations around Prague. So beautiful cliffs, about 60 meters high, just above the water, just above the river of Vltava. And on the right-hand side, in the right picture, you can see the man-made cliffs, and the which are on the right-hand side. So the buildings are the man-made cliffs, and then the natural cliffs. And the natural cliffs do have green roofs. They also have green walls. It's the man-made which don't. But they act really similarly to the environment. They reflect heat, they accumulate it, but on the other hand, they can also provide nesting locations for birds. They can also host a lot of biodiversity, and that is, I think, where the potential is. So you can see in this picture, it's a nice combination of civil engineering work and the natural work, and you can see that it can actually coexist in a nice symbiosis. And we can get some inspiration in nature for green roofs and green walls. This is a really basic, simple green roof with sedums, as everybody probably knows. And this one, this is from Norway, as you might recognize. It's slightly different. This is the example of the Scandinavian type of a green roof, the original one, which has been made since the Celtic area age. Yeah, it's made using a different technology. It's made using birch bark as the waterproofing, which is obviously layered, and on top of it, there comes a turf, or they call it a sod roof, so a piece of the natural turf that used to grow around the site. In reality, we meet a lot of our customers who travel to Norway, and they come with an inquiry to us, and they want to have this Norwegian type green roof in our Central European environment, and we have to explain a little bit that it's not going to work the same way. We need to adjust the vegetation buildup because the environment is different. fundamentally. So in Norway or in Scandinavia, you have a different rainfall distribution, for example, or even the total volumes of rainwater are different throughout the year. And that is really, and the temperatures are really different, and the whole climatic zone is totally different. So the result is likely to be very different, and that's why in our Central European climate, we adhere to this idea of a green roof buildup, which is the case for flat roofs. That's not the case for pitched roofs. They have a different one, but for flat roofs, the vegetation buildup is usually composed of these layers. So the vegetation, hopefully some which is local or typical and long standing. Then the vegetation layer, which tends to be the substrate filter layer, protecting fine particles from entering the drainage and water accumulation layers and clogging the drainage system. And then underneath that, the protection layer, which tends to be a geotextile fleece, and the last important layer, which is done and has to be done by the engineering companies, is a root-resistant layer, which is in most cases the waterproofing. So a waterproofing membrane or bitumen belt or any other really well done waterproofing, because if it's not well done, the plants are going to find out. What types of green roofs do we have? I believe it's not anything new to you, so you probably know all of them. So this is just what I will be referring to when I say extensive, semi-intensive, or intensive green roofs. So this typology is based on the amount of maintenance that we need to provide to the green roof. And then we can also distinguish green roofs based on the purpose they serve. So retention roofs, biodiverse roofs, biosolar, combining solar or thermal generation of energy with green roofs or production. They can be flat or they can be sloping, and they obviously deliver a lot of functions. So the functions of greenery, you really know this well, and I believe this is actually could be some of the reasons why you are studying what you are studying or doing what you are doing, because the functions of greenery are fundamentally satisfying, contributing to the healthy environment, humidifying the air, producing oxygen that we breathe, trapping dust particles and pollutants. And the most magical thing about this is that plants are doing this they're doing this for free, only they are using the solar energy and water to facilitate most of these functions. So that's really the fundamental difference to our engineering solutions that are sometimes taking the upper hand, unfortunately. So greenery really is the low-cost solution to many problems, and it's the most diverse of all. So back to green roofs and how they can actually contribute to the environment. So they obviously improve the microclimate, balance extreme temperatures, reduce the intensity of thermal radiation, increase humidity in the environment, reduce dust particles, protect us against the urban heat island effect, slow down the runoff and retention of rainwater, and return it to the natural water cycle. And they can obviously create replacement areas and habitat for flora and fauna, and that way they can support biodiversity. Regarding their protective and economic functions, so the protection of the waterproofing against UV radiation and temperature fluctuations, this is a really big thing in the Czech Republic because the most used waterproofing membrane is unfortunately very low performing in terms of UV radiation. So that's the PVC membrane, unfortunately. And when we cover it with a green roof, we significantly prolong its lifespan. And we also reduce the risk of mechanical damage to the waterproofing. We also reduce noise pollution, which is a really important factor of comfort in the building, especially in air corridors. We improve thermal protection, especially in summer, so less cooling. Actually, cooling in summer is beginning to consume more energy than heating in the winter, and that is likely to stay for the foreseeable future with us. So green roofs can really save some money in the summer. Reduction of pressure on the sewer network during heavy rainfall. It's a big thing, especially in the Scandinavian countries. I know that some colleagues from Copenhagen are dealing with this quite a lot, and also in the Netherlands. So especially the low-lying locations can be quite complicated regarding the sewage system. So the less water enters the sewage system, the better. Green roofs can actually make the water stay on the site where it actually falls. And using these benefits, green roofs help us adapt to climate change. Using sustainable water management, they help us maintain microclimate. Our air conditioning measures, and can be even looking like this. This is a project from Porto. If you've ever been to Porto, you might have been there. If you haven't, do go there because it's really interesting. It's a formerly historical site, which needed to be redeveloped a number of times. So formerly a marketplace, serving certain purposes, but then times were changing, the purposes were changing as well, and the site needed to redevelop. And this historical corner of the square stayed there all the time, and the square was changing its looks, so fitting underground garages when there were too many cars in the center, also featuring some shopping areas, some recreational spaces, and eventually it ended up looking like this. So all of the functions of public spaces are included at this plot. So underground garages for cars, shopping amenities, and a beautiful rooftop bar in a lush greenery. That is only possible using green infrastructure and green roofs. So with rainwater, getting back to the benefits. So the benefits of green roofs that can actually be felt are visible in this little table. So in the table, you can see that the water retention is actually in direct correlation with the build-up height. So the more build-up height, the more water can be accumulated, and the better for the city and sewage system as well. So using the evaporative cooling, we get a better microclimate inside of cities, and we also can mitigate some heavy rainfall events when they come, just like this one, which happened in Prague some years ago. I was lucky to be able to film it. But really, the rainfall distribution is changing. We see long periods of droughts, and then really torrential rains, everything falling at once. And the cities are not ready for this. That's why we need to install many projects like this, the green roofs, on the buildings that actually are already built in the city. Just like this former industrial building, which was built some 100 years ago and no longer served this purpose. It used to be a textile factory, and then it was bought by three friends and redeveloped into a residential building with about 11 apartments and this community green roof, which featured production parts and also a common part and it happens to be the only green plot or green area on the plot. A beautiful project, also award winning. And this one is very similar. It's in Bratislava, also a formerly industrial building featuring a beautiful green roof. In this case, the building is an office building. So a lot of the benefits are displayed in this picture. I believe we covered it. We covered it really nicely. So back to the Mentimeter. What do you think delivers most of the functions of green roofs? What is the element that is the single most important in terms of delivering for green roofs? So again, when a few of you have answered, I will share the results. So what do you think is the most important thing on green roofs using the in terms of the benefits? I'm already starting to get some answers. So I'll share the screen. So this is it. This is it. This is your answers. Great. Yeah, that's the benefits. Actually, the I see the answer that answers it all, and that is everything can be possible due to plants. It's the plants that actually deliver most of the functions of green roofs. So the roots of the plants, as I can also see there, they actually pump out the water from the substrate and evaporate it back to the air. The plants actually attract the pollinators and make it an interesting habitat. The plant leaves actually collect dust particles and can put them back into soil. Plants can photosynthesize by using, evaporation. Plants, provide us with the urban cooling. So it's all about the plants, and the more diverse we design the roofs, the better they are. Actually, the more delivering they are. So I'll get back to the presentation. So thank you for answering this one. So plants, here we can see like a pretty regular bee and a butterfly right in the center of a city on top of a green roof. When was the last time you saw a butterfly in a city? It doesn't happen too often, but we can have them on roofs, just like we can have a mantis on a roof. You can see them trying to hide here. There are two mantis. So we can really deliver green roofs for biodiversity. They don't have to be only aesthetic, they can really be delivering. So how do we do it? So how much load can I afford? That's the first and foremost question that we need to ask ourselves. So a regular extensive green roof would weigh about 150 kilos in our local conditions. If we want some more plant diversity, we need to add some more substrate. So the semi-intensive green roofs would be about 250 kilos, maybe to 300. And the intensive roofs would be starting at around 300 kilos per square meter in fully saturated state, and can go all the way to, or rather 1.5 tons per square meters if we want to incorporate really big trees there. No problem. So it's really about cooperating with civil engineers if their structures can actually fit such heavy loads. So that's the number one question. What look do I want to achieve? What should the roof serve actually? Do I want it just to be able to look at a nice green area? Or do I want to utilize the roof? Do I want to use it as a recreational space? In that way, I would need to probably incorporate some pedestrian areas there. So how do I want to use the roof? How much maintenance can I provide? So for extensive green roofs, it's very low maintenance, once or twice a year. Some fertilizing maybe from time to time, collecting some weeds. So it's really very low maintenance, but with intensive green roofs, it's basically the same maintenance as we would have with a normal garden. And on top, basically we need to take into account that it's on a structure. So we need to maintain water outlets clean so that no vegetation is growing in the water outlets. We need to make sure that the water outlets are accessible. That's one of the things that we sometimes see in landscaping designs when they're not done really properly. That we sometimes see that there is a tree sitting right on top of a water outlet, which is not really fortunate because the tree and the roots of the tree will be attracted to the water, which will obviously go down into the drain. So there needs to be a cooperation between the civil engineer and the landscaper, and that is also regarding the layout of the elements on the roof. So water outlets need to be accessible. Vegetation cannot endanger the civil engineering structures, etc. A lot of things to take into consideration. What is the access to the roof? How will I be even able to maintain it? Can I even bring a lawnmower to the roof? Well, I'll obviously not be able to drag it through a window. We'll need some better access. And what are my financial options? So the more material we install on the roof, the more expensive it will obviously be. And also, and we've already touched this, the need and availability of water. That's also crucial because with water scarcity becoming a really serious thing in our climate, and I believe elsewhere in Europe, because of the rainfall distribution changes, we need to make sure that the vegetation is actually performing and doing well. Because if it's not doing well, it's not going to perform. And vegetation needs water. So we need to think about where do we get the water from? So because I think you probably are familiar with some of the basic solutions to green roofs, I included some more innovative ones to get more technical. So that one of those are blue green roofs, and also I believe this is one of the solutions which is really picking up speed in the Netherlands, for example. So the blue green roof is one that can really harvest a lot of rainwater. So it can really nicely hold back the surge of torrential rain and slows down the runoff. And it retains the water on the roof for plants, and that way, from the perspective of a civil engineer, it's a very useful way of disposing of water. Civil engineers like to dispose of water still in the Czech Republic. That's the status quo. But actually, it's about using the water so that it can fulfill more benefits and can pay us back a bit. So how do blue-green roofs actually look? So this is one example from a company called Up to Green. I don't to advertise them too much. It's just that they have some nice pictures. So the difference to a classical extensive or semi-intensive green roof would be the water reservoir, which is really large. And this picture is from another company. This time it's Bode. Also a very similar thing. Now the interesting thing about the blue-green roof solution is that the water outlet is regulated. So the discharge of water into the drain is regulated by either electronically or using a built-in pipe with a certain diameter. And that way we can actually accumulate a lot of water on the roof, and then the vegetation, it needs to be accessible to the vegetation. The vegetation will be able to pump it out and cool down the climate, grow all the benefits. And another solution, it's the same solution, but another company called Wawin or Wawin, I don't know. It's pronounced differently in every country, I guess. What are the prerequisites of blue-green roofs? So the single most important is that the roof has to have a zero pitch. So that is, it needs to be perfectly flat, because some of the blue-green roofs actually retain a permanent layer of water. Some of them retain a temporary layer of water, and obviously the layer of water needs to be even on all of the surface of the roof. So that's why there needs to be a zero pitch. There's a little thing with the Czech market, because this is not the way that roofs have been done historically. Civil engineers like to use a little slope just to make sure that the water actually flows away. And that gets in the way of blue-green roofs here, but it doesn't have to be a problem actually. The most important thing there is the waterproofing, and also like the structure, the ceiling needs to be really flat, so no puddles, no deflections. But the single most important thing, the waterproofing, because the water will exert a certain amount of pressure on the waterproofing, and if there is a leak, then you'll have a ton of water literally in the roof, and that's a serious problem. So the waterproofing needs to be pitch perfect, really, for blue-green roofs. I would also recommend some leak detection system for that. Now we can use these technological solutions for blue-green roofs, or we can use the natural solutions, sort of. So we can create some temporary or permanent wetland biotopes on roofs. So the picture on the right-hand side you've already seen, that's the lake with the turtles. And the picture on the left-hand side by Zinko is a nice creek running through the whole extensive green roof. What there is a nice project from Berlin is on top of a psychiatric treatment hospital. And this green roof actually serves multiple purposes. It's an intensive one, a blue green roof, and it is maintained as a part of the therapy. So there are therapeutical sessions actually on the roof, and as part of the therapy, maintenance is done. Some of the other rather innovative solutions are biosolar roofs, or solar green. You know that electricity or thermal energy can be generated using the energy of the sun, or even both kinds of energy at the same time. And all of these systems can be fit together using green roofs. So this is the solar installation, this is the solar thermal, so photothermic installation, and this is both photovoltaic and photothermic panel. So the benefits of doing this is that we get all of the green roof functions, and we also get all of the PV functions, and we also get something on top, so something extra. So it's this weird equation 1 + 1 = 3, because what we get extra by combining green roofs and photovoltaic panels, for example, is that we get a better habitat actually on the roof, because it's more diverse. We get some shady areas with a permanent shade, some semi-permanent shade, some sunny areas. So that's already 3 kinds of a biotope on the roof, which also fosters greater biodiversity. So that's great. And because of the cooling effect of the vegetation, we also get a slightly increased yield of the photovoltaics. So that's a nice side benefit as well. So on one area, we can get multiple uses, and it's a really win-win solution for the future. And there are a number of ways how to install green roofs and photovoltaics. It can be done well, or it can be done wrong as well. So the problem with the crossed pictures is that the vegetation can actually overgrow the panel. It's getting more water underneath the panel lower edge, and therefore the vegetation will grow more and can actually overgrow the panel. So that's the bad kind of installation. But when the panel is raised above the level of the substrate, the vegetation will not overgrow it if there is the right kind of vegetation, obviously. And that's when we get the synergic effects. So then it can look like this. This is one of our installations, or this is from our colleagues from Switzerland, a beautiful bifacial solar installation. It is a really interesting solution, and I think one of the solutions for the future. We can also think of green roofs as biodiverse green roofs, fostering biodiversity in the city. We should use maybe the typical plants of the area, and we should make sure that the green roofs deliver for animals as well, so small insects or spiders, but even birds can have some nesting opportunities on green roofs. And what we have learned from many biodiversity studies on green roofs is that diversity stimulates abundance. So the more diverse we actually create the environment in terms of habitat, in terms of plants, in terms of designs, shading, and all sorts of things, the more the species we will actually enable on the roof. And we also know that the more species, the more resilient the roof is. So that's another benefit. So this is again an example from our colleagues in Switzerland. Green facades. So it's not maybe always about green roofs. Sometimes it makes sense to green up the facade as well, using an intensive green facade or vertical garden or climbing plants. This is the 2 solutions compared. The picture on the left-hand side is in Brno, and the picture on the right-hand side is from Zurich in Switzerland. A very diverse installation of climbers in public space on a steel construction. Or this is not a surprising picture. Or this one, a high-tech solution by Laura Gatti Architects in Milan. So Bosco Verticale, vertical forest. Yeah, and these solutions are really picking up speed together with green roofs. You can see the growth of the green roof sector actually in the Czech Republic, just so that you get the perspective. So about 10 years ago,
we had 110,000 square meters of green roofs newly built in that year. We don't have the figures for last year still, but it's estimated that it's going to be 4 times as much, 4 times the numbers that we had 10 years ago. So we get some exponential growth in green roofs in 10 years. So what we need to learn for the future. So first, learning from what was done wrong, learning from past mistakes. So things like the vegetation does not grow without water. It will not grow in rain shadow. So there needs to be some gravel or tiles or just a place without vegetation in a rain shadow. We cannot accept that without irrigation there would be vegetation growing. This is one of the most important things, the waterproofing. Because if the waterproofing is actually bad on a roof, just like you can see in this picture, it will actually spoil all the benefits that were supposed to be delivered by green roof. And that's what we are seeing, unfortunately, more often than we would like in the Czech Republic, that the quality of the waterproofing is not really good. And if the waterproofing is leaking, the water is going to go there. If the water goes there, roots will go there as well. They will expand the leak, and obviously the insulating layers will be filled with water. We'll get some leaks on the inside of the building, and all of the roof will need to be reconstructed. No one will be happy about it. It's a lot of work, a lot of costs. From our experience, the costs of redoing a green roof completely are 2 to 3 times of the installation costs, basically. So it's good to avoid this and really test the waterproofing before it's covered. So when the waterproofing is done, it's a good habit to invite some third party who will test the quality of the waterproofing using various methods, certify that it's done right, and then it can be covered. So that would be a nice practice to have. Soil instead of substrate. We don't see many of these installations, but sometimes when the pressure on the costs is big, we see that soil is being used instead of substrate, or bad soil is being used instead of substrate, and that obviously does not lead to the desired outcome. Maintenance. Greenery needs to be maintained, at least a little bit, for the extensive roofs. Here in the picture you can see a gravel roof, which was supposed to be no maintenance, but any roof requires a maintenance, even a gravel roof. Our norm actually stipulates that even a bare roof with no vegetation, no gravel, requires a maintenance once a year. If it's not maintained, there you have it, a tree growing from the inverted system of thermal insulation. Yeah, so we need to learn how to do it better for the future, to have really sustainable solutions. And our association provides a lot of resources. You can, if you want, if you like, you can download some of our publications here. This is regarding the greening up of facades. If you actually take a look at the website of the EFB, so the European Federation of Green Roof and Living Wall Associations, it will link you back to your national association, and the national association can also provide some of the resources in your national language as well. So it's not this is only Czech. It's not translated into English. We have our green roof standards, also in Czech, can be translated with deep L maybe. We also, as of March, we have a technical norm for green roofs. So that's something that we have done in cooperation with the civil engineers, because they are also interested in the topic of greening up buildings, and it's a big success for the industry, because it will enable civil engineers to really design green roofs the way they should be, so that they deliver for the long term. We provide a lot of education, expertise, and quality assurance. So seminars, workshops, excursions, certification of installation companies that we just launched a couple of months ago. And also last year or the year before that, I don't know, we prepared the national qualifications framework for the green roof contractor, just to make sure that the industry is ready to deliver. In the future, I believe we will need to be more mindful of our carbon footprint and of the impact that we make on nature. So things like carbon neutrality and net gain for nature, or net gain for biodiversity, will be really of interest. We will need to argue for green roofs using the language of the audience, so to say. So when talking with developers or investors, sometimes it's good to mention that green roofs and greenery actually in the ground actually pays off, and it pays off sooner than they would think. It can attract more publicity, more interest, more revenues, and therefore it can pay for itself, just like green roofs can do. The greenery underground can do as well. So we need to make sure that we build buildings for decades to come, and they need to hold up in future conditions. They need to be future-proof, fit for the future climate, which is so far not reversing, unfortunately. We are actually currently also dealing with one interesting project, which is called Go Nature Positive. So talking about being, having a net biodiversity gain, net nature impact. We launched this project in a consortium of really great partners under the Horizon funding just recently, and it's very exciting, very promising. So if you're interested in this field, make sure to follow this project. We're doing the project together with the Aarhus University, Oxford, Trinity College in Dublin is the lead partner, and also the World Wildlife Fund is there as well. It's going to be an exciting project. In the future, we assume that more regulation will come. Hopefully, even the nature restoration law, which is currently hanging in limbo in the Council, the European Council. Yeah, we hope it's going to be tabled again. It was held back, unfortunately, when it almost passed. It was held back, and the nature restoration law actually argues for the urban green environment, for more green roofs, more green walls. It also argues for combining the green roofs with energy generation, so biosolar. So we hope that this will actually find its way into reality, because it's really necessary, not only in the cities but also in outside cities. We will need to look into what we are actually using to green up buildings. So what plants are we using, and what materials are we using in which the plants are supposed to grow? Are they actually environmentally sound? Are they delivering the most they can? What is the carbon footprint behind them? Can we use some bio-based materials? So that's the kind of questions that we'll need to ask, and that you will need to challenge us with as the upcoming generation of landscapers as well. Yeah. So where to start? So anywhere, basically, looking at the buildings that we have at the present and thinking about what do we actually need there? What is pressing us? Do we have all the information? Should we consult with anybody? With a civil engineer, with a landmark protection authority? What are the costs of the measures that we would like to see? Will they actually pay off? When will they actually pay off? So it's about starting somewhere, talking with people from various backgrounds, because the things that we're dealing with are multidisciplinary, and hopefully we will soon start seeing some green results, or more of them in the future. So this is all from my part, and if you have any questions, I am obviously more than happy to answer. And in case I am a little bit over time, so I don't know how much time you have, but yeah, also you can get in touch if you would like, and yeah, I can answer your questions at any time later. So thank you for your attention, and if you would like to ask anything up here.